Alright, so for these ones here, we have some right angle triangles, as you can see with the 90-degree mark, each one of them. And we are to find the angle, and down here we are to find the two angles in the other side. So let's start with an example from number 1. The first thing you should make sure you know how to do is identify the sides. So if I draw a right angle triangle, like so, and the little right angle triangle here showing that it's 90 degrees. Try that again. So 90 degrees. We can see that this will always be the hypotenuse here. And depending on the reference angle, we have to identify the opposite side and the adjacent side. So if this is our angle here that we're looking for, then opposite side is right here, OPP. And this would be the adjacent side. Alright, so for the example above, let's do number 1A. So that triangle looks something like this. Here, here, and there. Alright. And we have this angle that we're looking for in here. This is 90 degrees. We have 3 centimeters here and 2 centimeters here. So depending on which sides we have, it allows us to figure out if we're going to use sine, cosine, or tan. So in this example, if this is my angle, I have my opposite side is equal to 3. And then my adjacent side, which is attached to this angle, is equal to 2. So in all of these 3 here, we have the ratio O and A. So I'm going to have tan of an angle is equal to O, which is my 3, on my A, which is my 2. And since we're searching for an angle, we have to remember that we should have our angle is equal to the inverse tan of this ratio 3/2. And then we have to make sure that our calculator is in degrees. And when we do this and try to figure out the angle, we get 56.3 degrees, and that's 3 significant figures. So there's our angle. So there's an example of 1A here. So we can use the other trig ratios to find some of these. You'll find that we will have 2 out of 3 sides for part A, B, C, D, E, F, and G, H, I. So identify one of the trig ratios that you need to do with the sides that you have. For number 2, if we want, we can look at that one. So if we take number 2, and let's try and find this. Let's try and find this side x. Okay. So in this case, if we do that, we have the triangle that looks kind of like this. And the easiest way to find that angle, I think, is using Pythagoras. So we have x here, 5 here, and 8 here. And we have to remember again that you can only use these 3 trig ratios with right angles. And you can only use Pythagoras with right angled triangles as well. So Pythagoras says a squared is, let's see what I try to say. A squared plus b squared is equal to c squared, and our c squared is always our hypotenuse. So if I write my equal sign, my hypotenuse in this case is 8 squared. I have one side. I can label this as my A, and I will make this my B. So A 5 squared plus b squared. Bring this over here. Rainbow over. I have b squared is equal to 8 squared minus 5 squared, change the sign. B squared is equal to 64 minus 25. We do the subtraction, we get 39. And then we square root both sides, so we get b is equal to square root 39. Or, if you want to put the decimal form, b is equal to 6.24. And in this case we have centimeters.